Hello, everyone. So we'll be waiting for our usual 5 minutes to get everyone connected. Nice to see you all here. So I've put the link to the for note taking in the chat. And while everyone is connecting, I'd like to wish everyone Happy New Year. We're still in January, so let's say that there's still time for that. I'm not sure, can you hear me well like this?
Yes. Hi.
Okay, thank you. Perfect collision. Now, perfect interference. Now, a little timeout, and yeah, we'll start again. Okay, so we are almost 5 minutes after the top of the hour, so we can start. So hello everyone, very happy to see you again this year. So this is our first interim meeting for this year, and we have some interesting topics to discuss. This is an official IETF meeting, and as such, all IETF policies apply. By participating, you agree to follow IETF policies and processes. If you're aware that any IETF contribution is covered by patents or patent applications that are owned and controlled by you or your sponsor, you must disclose that fact or not participate in the discussion. Yeah, like the whole note well applies. So please take the time to read the full documents that are given in this in the references here. So for today we have two items, two main items. So the first one is discussion, like the presentation on the SCHC draft, and a second presentation, which is on a new draft that was submitted last week on SCHC universal option. Do you have any other items that you would like to discuss for today? Okay, so let's keep it to these two. Yes, Laurent?
Yes, we have also to talk, maybe not today, but about to request a seed for the data model.
Okay, so let's see. I think, do you have any slides about this one?
No, but if I follow your rules, it's something that has to be discussed in the working group.
Okay. I think that this. Oh, I fully agree with you, but maybe probably we'll need to have some slides just to have like the support on which to discuss, because like the seeds are a little bit. How can I say? To get everyone on the same page, I think that we need to have some slides, at least to like visually to represent the questions at hand. But like let's see at the end if how much time we have on this. So thank you, Laurent. So with this, I just want to have a very short status update on the drafts. So the first thing that is that's important is that there was a new version submitted of the SCHC architecture draft. So again, we are going in really consolidating all the discussions that we're having and trying to have a common view and a shared view that is, of course, a consensual view of the architecture. And this document is a step in that direction, and we'll have a presentation on the evolution on the next interim. So that's the first big item. Then another item is, I would say, the addition of the new draft from Laurent. Other than that, like things have not evolved that much since the last time that we spoke. Right. So with this, I'm going to give the hand to Alejandro, who is going to present the SCHC fragmentation, like some discussion on the SCHC fragmentation, SCHC rule, sorry, on the SCHC. So Alejandro, I'm giving you, let me give you the control of the slides. So.
Oh, nice. Thank you. Do you hear me well? Everyone hears me well?
Yes, I hear you well.
Okay. Yeah, so this part is just to pick up again the discussion about the FEC. So right now we have a bit more ideas and complementary information. And anyway, after the holidays and so, like to retake this and see what your opinion is about it. So first, our initial proposal was creating a new type of rule called FEC fragmentation rule ID. So it would be bound to an existing fragmentation rule, and therefore it will inherit their parameters, and it will extend the fragmentation functionality to add a FEC fragment every now and then. I think a big advantage is that it does not alter the existing fragmentation functionality, so we get some backwards compatibility. What this means is, in case if someone, a node does not recognize the FEC operation, it will simply ignore the packets, and fragmentation would work as usual. So this is what it looks like. So a set of rules would be comprised of compression rules and fragmentation rules. In this specific example, I have a compression rule of with ID 10, a fragmentation rule with ID 20. Of course, fragmentation has their parameters like FCN size, window size, etc. And now, according to this proposal, there would be a FEC rule. In this case, it's the one with ID 30, and one of the parameters is to which fragmentation rule it would be bound to. In this case would be the previous one, so rule 20. And here we just extend with additional parameters. So for example, send an XOR frag, so a FEC fragment every 2 regular fragments. So this would inject FEC fragment into the traffic, which could be used by the receiver to recover lost fragments. There's an example in the next slide, I think. I will go through it. So as I said, so the FEC fragments would be identified through a new rule ID, a separate one. However, as it is bound to a current fragmentation rule, then this is how the SCHC, well, I'm sorry if I don't use the correct syntax right now. I know it's a bit of a mess, but the SCHC entity would know how to process it. And if the SCHC entity does not implement FEC, well, it would simply ignore it because this FEC operation or FEC rule is not known or supported, so he just ignores it. And then the other fragments are done as usual. Yeah, endpoint. Okay, the SCHC endpoint. Thank you, Laurent. So of course, some weak points, maybe a lack of adaptability. So in this case, we were considering just XOR, the XOR operation. And one argument against it would be, okay, so what about other FEC algorithms and the data model? So we realized that, so of course, for the proposal, this was just a first draft. Was just presenting the idea, but of course this FEC rule would have to be defined in a data model, and we're working on that. So this is what this would look like. First of all, on the top we have 3 fragments. So fragment A and fragment B correspond to fragmentation rule 20, and they are built and processed as the standard right now specifies. So the FEC fragment would be now injected into the traffic. So every 2 fragments would then build or make up a FEC fragment, which is the XOR operation of the 2 previous tiles, group of tiles. And like this, well, if the receiver has at least 2 of the fragments, 2 out of 3, then he can it can recover the missing one. Previously, in the previous draft, there was also, or at least in the previous version, there was also a problem with the FCN number. So we said, okay, FCN will point to the last tile of fragment B. But we agree that this breaks a bit the concept of FCN, which always points to the first element. So now we say, okay, so the FCN will make a reference to the first, to the beginning of the data that can be recovered. This is an example with sparse losses. So of course, if nothing is lost, then everything is happy. And if everything is lost, well, FEC doesn't help us much. But in sparse losses example, we have, for example, fragment 1 that arrives. Fragment 2 is lost. But the third fragment, which is a FEC fragment, is received. And so it is used to recover fragment 2. In the next messages, fragment 3 is lost, but fragment 4 is received. So again, we use the FEC fragment to recover fragment 3. Finally, nothing is lost, so we get integrated check OK. And like this, in reality, we lost 2 fragments, but we were able to recover them. In this case, if we send, for example, fragment 1 arrives successfully and fragment 2 arrives successfully, even if we receive the FEC fragment, well, there's nothing to recover, so nothing happens. Yes, Anna, tell me what's your question.
Hello. So as we had discussed last time, I don't see the difference between what you are doing now and what we have discussed. About that, using a new rule ID means having a new flow or new packet, and it's not in the rule ID 20. How you are merging rule ID 20 with rule ID 30?
So I hope this answers the question. It's the fact that rule 30 is bound to rule 20. So the packets tagged with rule ID 30 are like the data, the properties are inherited from rule 20, and this is how the endpoints can process them.
Yes, but how can you say that rule 30 is not another packet different from your FEC? You have nothing to define that.
You have nothing. What do you mean
Yeah,
when
you
you say that I have
what I
nothing? For
mean is that
example,
you are changing the fragmentation process that has been already implemented in 8724. So here you are saying that rule 30 is your FEC rule ID, and if
yes.
somebody has not implemented this idea and use rule 30, that will not be a FEC. So how can you define that rule 30 is the FEC in all the implementations you have?
Well, precisely because the concept of SCHC, if I understood correctly, is that they have to have the same context. So of course, if on one endpoint, even rule fragmentation ID, fragmentation rule ID 20 is not the same rule ID 20 in the receiver, of course, there's going to be a mess of communication.
So you
Otherwise,
mean that you will never use your FEC?
you will never. Yes, I will. You would use it when you tag the FEC fragments with rule 30 in this case. So using this specific set of rules, whenever I send a packet tagged rule 30, the receiver
All the
processes
implementation
it.
will not have that, so you will not use your ID 30.
Both implementations don't
The
have it.
old implementations, those that will not implement this FEC.
Yes, exactly.
So,
So if a node does not implement it, then
so
like
you
if a
don't have
node does not implement FEC, there would be no FEC. That I agree. Yes. And the nodes that implement FEC, they would be able to still communicate with nodes that don't implement FEC, and the ones that implement FEC would be able to use it normally, as intended here. Yes, Laurent?
Yes, for clarification. So I think what you are representing here is a set of rules, and you have a rule ID associated to compression, a rule ID associated to fragmentation, and you have also a rule ID associated to FEC. So each
Yes,
of
correct.
them are different rules.
Yes.
Okay, so that's maybe where Anna is thinking that if you receive an ID, so in fact it's 30/8 or something that gives you the ID and the length, and if an implementation doesn't know what is a FEC, we hope that this implementation will not collapse and say, I don't know this buzzword or this keyword.
Yeah, in theory, that's the theory. So if a node does not implement the process FEC, of course we will not be able to use FEC. But if the nodes that implement FEC, they would be able to still communicate with the nodes that don't implement FEC. And we don't disrupt the fragmentation, the current fragmentation standard. So it's like an extension to fragmentation rules. Okay, I'm gonna move on because this is not the only point to discuss here. This is just a packet evaluation concerning 10 packet loss if we get 2 out of 3 packets. So using only XOR, we get 2.8% of probability that this method doesn't work. So we have 97.2% that it works. So another argument now is to use.
Wait, sorry, Alejandro, can you go back just a second?
Yes. Back where?
No, on the next slide. So, what you said is what? With 10% packet loss, what happens?
So in a scenario where, so for example, in a LoRaWAN deployment where we have 10% packet loss, so every 100 packets that the devices send, 10 are lost.
Yes.
If in this network we implement FEC, we would have a 2.8% probability that communications would be would remain the same, like disrupted. Like these packets would not go. The missing packets would still not go.
So you mean that? Okay. So actually there are two things. I mean, I need to look at the model here, but basically it depends on the distribution, right? If you have from 100 packets and you have the first 10 packets that are lost, then you're going to have to resend. You're going to have to resend some of them, right? But 10% packet loss. Like if I pick the lost packets where they happen, I can lose up to 33% of the packets in a network, and it will work with no problem.
Exactly.
Yeah. So every 2 packets, and then I lose the third one. So up to 33%, it works with no problem, right? So I'm not sure if I understand correctly here.
So this 2.8% is just so actually it's the probability that with this FEC mode enabled, these packets are really lost.
Okay, so it diminishes the packet loss, and you have like 2.9% only from 10.
So exactly, so it diminishes the packet loss eventually probability by the complement of this. So this is the probability of 2 or 3 lost packets per 3 packets sent.
Okay, I see. So I need
the probability that this FEC doesn't work is 2.8%.
Okay. Yeah. And but there is also one thing, like you remember that it's like we can configure this FEC fragmentation mode to have more than one XOR. So,
So,
we can so that diminished if you want.
So this example is done with like sending, like this. This example is considering this example. So we send two fragments, two regular fragments, and the third one would be a fake one.
Yes, exactly.
So in this example, we have 2.8% probability that the fake does not work. So it's very low.
Yes.
Actually, for practical reasons, it's acceptable. Okay, I'm gonna really turbo through the rest of the slides. So concerning, say, you said, Alexander, that if we lose consecutive packets, then of course nothing works. So yes, this is something that we thought of also. So if the regular fragment tiles go like 0, 1, 2, 3 until n, we start adding, so we start interleaving the FEC data at the tile level. So we make the third tile be XOR of T0 and T1. And then we send the fragments with mixed tiles, so or with interleaved tiles. So we have the first fragment is not really the first three tiles, but the tiles 0, 2, and 4. And then the second fragment is tile 1, tile 3, and tile 5. And then the third fragment, or the fragment which would be the FEC data, would be the XOR between tile 0 and 1, XOR between tile 2 and 3, and XOR between tile 4 and 5. So this gets rid of the burst error mitigation potentially. So because if we lose consecutive packets, we like it redistributes the missed data. And then we have, okay, this gives a bit more robustness and better decoding performance, just because it's more likely that we get the consecutive data. So another option is to add a FEC and recover layers on the stack. So when we have the application data, then we compress it, and before fragmenting it, we run a FEC algorithm operation. So a traditional one, like say read Solomon codes or so. On the receiver side, on their assembly, we just add a parameter that says, okay, we accept n out of k fragments, and then we use the recover function to recover the original data from the n packets that we received, even if the total was k. So of course, we would love to get more feedback on this, have more FEC experts talk. We are contemplating getting some LP1 sample traffic, particularly from activity side. See how this would behave there. We still have undefined behavior on MTU change, but we are considering that well, just not define this handling. Eventually, MTU change, according to what I understand, is like something that happens really exceptionally, and it means that the network is overloaded or in really bad shape. And of course, implementation requires evaluation, but this is out of the scope for now. And I think that's it. Yes, Anna?
Yes, for me is do we need two solutions to do FEC?
We definitely don't,
Reporting in two
but I'm
solutions?
not. Yeah, we definitely don't. I'm just trying to get some feedback on these two options. What would be the best?
Well,
According,
I
we
think
already had a.
the
Sorry, let
first
me
one
just
doesn't
finish.
work, and the second one is very nice from my point of view.
So on your point of view, the first one doesn't work, yeah?
No.
And this one is very nice, you say?
Yeah.
Okay, we'll have to discuss more about this anyway. Anyway, from the industrial standpoint, we talked a bit with Actility, and they do prefer XOR, especially with the tile interleaving feature. But I think the time is up. Well, we can discuss this further on. I will contact you, Anna, to discuss more about your argument about associating a FEC rule ID with a fragmentation rule ID. Okay.
Yes.
I really want to understand your point.
Okay. Of
Okay.
course.
Thanks.
Yes, Alejandro. So just actually, I remember that we had a short discussion. We had this kind of like this discussion at the IETF in Dublin, and there was so as Anna says, like there is a preference to having one solution. And there are many people in the room that said, yeah, we really like to have one solution. And in the room there was a very strong consensus for the XOR to be implemented for several reasons that were discussed. And actually so Pascal even mentioned that it would be possible to use that for network coding in other settings in other deployments, like not in a star topology of SCHC, where you can send several XORs. If you have multiple links, you can have sent XORs over the links, and that can get to like improved performance, like in some way or the other. So you can really benefit from this mode. Right? But it's important that you. Yes, just I'm finishing and I'll give you but it's important that we took the discussion here and like we will be interested to see when we can have a working implementation.
Yes, it's what I was about to say. We need some simulation or implementation to see which one works or not, and so it's very important to take the decision. Because if you talk about having a hierarchy of XOR, I'm not sure the first solution works.
Okay, I'll try to order the ideas and discuss this by email before the next interim.
Perfect. Thank you very much, Alejandro. I think it was really useful to have the overview of the two modes and to actually get back into our heads the FEC fragmentation mode. And I think like what's interesting here is to see like how we can use then the fragmentation once we have this mode, then to use the fragmentation as a reliability layer for small messages, right? When you can have individual messages, each of the message being like a fragment of like something like a fragmentation session, but it's not going to be a real fragmentation session, right? And then add the FEC on top of that, right? So that could really make a difference for small messages, and not only for bigger messages. Okay, so with this, we move to the universal option, and Laurent, I think you're the presenter, so you have control.
Okay, thank you very much. So I want to share with you today a work we have done with Marco and Anna about universal options. So it's something that can have some impact on CoAP compression or CoAP data model, but can be also generalized to other protocol that has options. That's why it's called universal, because it's not only for CoAP. So what we want here is not to have a solution, but more to have a discussion on where we go, because there is a change, in fact, is from the fact that at the beginning we have SCHC compression that was defined in the LP1 context. It means that we were in a very, very static environment where we can predict a long time before using the implementation the traffic that we will have on the network. So, and for that, we create in the young data model, so in the RFC 9363, we defined a list of field IDs that concern mandatory fields and also optional fields. And so it has been defined, and if you are in a static environment, it works well. But now, as you know, we are no more in a static environment. We are the group has been rechartered for SCHC, and it means that now we have something. We are in a dynamic environment, and everything evolves around the SCHC implementation. So what happens is, for example, and it's something that Quentin raised a few time ago. So it's that now we may have options that didn't exist when the SCHC implementation has been made, and we still we have to be able to compress and decompress these packets. So in fact, the compression by itself is not modified, because compression is quite agnostic, but it's more a problem of representation of the option, and also how decompression, for example, if we compress a value 20, how the decompressor will know that we are doing decompressing value 20. If we have compressed it, we don't set it. So that's some discussion. Thank you for Quentin to have raised that. And I would like to have this discussion. I see that Quentin just arrived, so that's perfect. So just to remember how SCHC works. So you have a packet that arrives on a parser. So the parser will transform the header into what I can call an abstract header, which is a normalization of the header with a list of fields that represent this header associated to values. Then we need a rule selector, and the rule selector will look in the set of rules that are in the database, and what we need is that the field ID that is in the abstract header is also the field ID that is used in the set of rules to describe the rule. So this can be local, it doesn't have to be universal, but we need this mapping at this point. So once we have found a rule, we go to the compression. In compression, we send a SCHC packet at the other end. It starts with a rule ID, so we are able to find the correct rule to decompress it, and we decompress the information. And then we send the packet. So now suppose that we want to be a little bit clever and to have dynamic compression. So for example, we install what I call a rule creator, which is something that listens to the traffic and create rules that will be stored in the set of rules. So this way we have new packets that arrive, new traffic, and we can adapt the rules. So this is not the scope of this presentation, but we may imagine these kind of things. So the problem is how to represent options. So we have options that we already know and options that will appear in the future, or options that are proprietary. So how we represent them in the rule that will be created by the rule creator. On the other, so if we continue here, and Alex, I will give you after you can ask question. So the set of rules will send it to management, and management will set up this rule. Also, we synchronize this rule on the other database. So when a packet arrives, we have something compressed, and how we know the option values that was used before, because if we don't have a, we will not know it. Alex?
Yes, I mean, something just appeared in my mind while you were presenting. Is it possible for the rule creator to actually invent some of these options on the fly?
Yeah,
I mean,
he can invent it, but if he invent a random number, for example, when you use this random number for compression, it will work. But when you send it to the decompression has to extract this from this random number the option number that was initially used. So this is quite complex because you have to do a mapping. And when we do this mapping, and this is, I will say, a mistake that we have now in the SCHC representation, is that we create a kind of interoperability because we need a table that say this SCHC view of the field ID, in fact, has this value in the protocol space.
okay, yes.
So, and here it's where we had a lot of discussion in the mailing list and also outside of the mailing list, is that in fact we have two possibilities or two vision of things. So the one we had originally at when we did compression is what we call semantic approach, which means that we don't really care about how the information is represented on the wire, but we create something abstract that has a field ID, then a position, a direction, a variable length, for example, foo, etc. So here we don't look directly at the co-op option, and as I said, it can be extended to other kind of option, TCP, quick, or anything else. We create our own vision, very abstract vision of the option. And Quentin proposed to say, okay, no, don't go too that far, and instead look at how co-op is coded on the wire, and we have a type, we have a length, or we have a delta type, we have a length, and we have a value. So we are going to send these three fields, or compress these three fields using the SCHC principle. So when we do equal not send, both of them are equivalent, because since we don't see send anything, so the result is 0 on the wire. But if we look, so here, for example, but Quentin's advantage is that if you have a new option that appears, it doesn't appear in the field ID part, but it appears in the target value. So here we keep the same value as in the protocol options, and we can send it or not. So here we have no interoperability problem with this option. But from our point of view, so using syntactic representation can lead also to unoptimal compression. Because in fact, if you look at so if we look at the semantic one, if I want to send the value that is in the URI path, I will have to send on the wire a residue that say my residue is 3 byte long and the value is FOO. If I am doing it using the syntactic approach, then I have three fields to send. So the first one can be the type or the detail type is not a problem. Type or detail type is just a relation between the parser and what we send after. If the parser adds the previous option, we send the type of the option type. And if we don't do this addition, we are sending the delta. So it is quite equivalent. Then we have to send the length. Yes, Quentin?
Yeah, thank you for the very nice layout of the program. The quick question and something that I don't know if you are going to address it later, but the question is how generic is going to be the unparse function as well?
Yeah, I will go after to
okay,
that.
so forget about it. Thanks.
Okay, so here what we have, in fact, it's if we go to this syntactic approach and we want to be as generic as possible, if we have delta or not delta, is that in the standard, these fields are viewed as 16-bit long. So it means that if you do, you send it, you fix here, for example, a value of 16, and then when you send it, for example, you want to send the value, so 3, that is the length of what you are sending. So you are going to use a 3-bit for it. And maybe after that, you will send 3-bit for here, the third residue, that will be the value. And here it's because, in fact, CoAP is implementing internally its own kind of compression. And here, when we go at this point, we have to go to the real definition of all these fields. So we can also make, say, okay, we are going to create a rule with length for option type of 4 bits, another one with 8 bits, another one with 16 bits. But here we have all the combinations that is possible, especially if we have multiple options, and it leads to an explosion of the number of rows. So another solution is to create a new function for the length. So here we solve a little bit the problem, but you see that in that case, the compression residue is larger than the CoAP that's the CoAP has sense, because we cannot use this trick. So so that's the problem. In fact, I'm cheating a little bit in this representation, because if you look at the semantic, we have fixed here the field ID, and in the second one, we don't fix the field ID. So we are very, very generic, but in fact, we don't have a very, very optimal compression. So what we, so it's what I say. The problem, and I think it's something we have to study because we never look at that very closely, is that if we go too close to the wire, we will have something that is not optimal. So going more to the semantic makes the compression better, but it has to be understood more to know where we are going. And so to conclude, so what we would propose, in fact, is to change a little bit or to augment the rule format we have already defined. So usually we have just a field ID, and here, so sorry, I think the name is not good, but we have a space ID. Let's say, for example, I am working with the CoAP, and so here we have field ID CoAP option that will indicate that we are in the space ID of CoAP. If we are doing a TCP, we can have also a field ID that say it's the TCP options. Then we send the value. We take the value that comes from the protocol. So, for example, 11, and then the rest of the rule is unchanged. So this way, we have no more interoperability problem, because we keep the value that is used to describe the option. So the only drawback, I will say, but I don't know if it's a drawback or a feature, is that we have already defined the young data model, and if we say this is seed ID, in fact, is the field ID, the young data model will not work because SED doesn't make a key. We have to make a key, we need to have the space ID, and we need to have the option values. So now in the data model, we have 4 values: space ID, option value, a field position, direction indicator, that are needed to represent this kind of things. So normally it's good in the sense that what we have already defined for mandatory fields remains the same. We don't change, we don't add extra byte, but for options, we had this new representation in the rule that is totally generic. The only drawback is that we have to augment the young data model with this information. Okay, so that was my last slide.
Thank you very much, Laurent. Yeah, very interesting. So very interesting proposal. So just to walk me through the solution here. So the first, in terms of space, maybe we can use a namespace. I think that is what we're aiming at. Then, sorry.
Too much seeds.
So the second question then here is that so imagine let's imagine that we add a new protocol. Let's say we add MQTT, right? So we need to define a new Yang model that extends the SCHC data model, and there define the field IDs that correspond to MQTT. I mean, this is the way we defined it today, right? We have like FID -MQTT -topic, let's say, right, and all that. Like this is a little bit of how can I say a more generic question. Do you think that there can be a place to say, okay, well, I'm having MQTT protocol. No, sorry. Actually, I have two thoughts in my head, and they're mixing, and it doesn't make it's not coherent. But why then do we need to define the namespace ID here?
It's because when you, for example, you have 11 that is TCP and 11 that is for CoAP. So when you do your parsing, you need to don't. If you just put 11, you will not be sure if you are in TCP or in CoAP. So you have to represent this header is from this information come from this protocol.
Yes, but you already have it in the field ID, right? Because I have
more. In this case, we have no more field ID. Field ID is another entry, so this entry has to be autonomous by itself, and say because maybe if I have MQTT, for example, I can have TCP then MQTT. So I have to make the distinction between these two kind of options.
Okay, then, but then I mean, I'm not sure you can delete a Yang leaf, because basically you're saying for entries that have this option space, this SCHC option, they should not have field ID.
No, so you augment, and as you say, you have. So if you look at the draft, I don't put all the data model here, but look at the young data model, and we augment the list describing a rule or compression rule by adding this. So you can be either something with field ID or something with space ID.
Okay, then, but both SID and FID. In SID is space ID. Okay. Oh, please don't reuse SID.
What I say, there is too much SIDs.
Yeah. Because it's if you want name ID and can call it NID, but it's already overcrowded. The SID. FID will make it ambiguous. Yes. Okay, and there's also content that we wanted to ask. But okay, thank you, Marco, also for protocol space ID. Yes, but then again, I mean, I'm not sure. I mean, why don't we just let's say it's field ID feed -coap. Because you are saying there are many options that exist, but then we can simply define a new field ID type, which is coap option.
But that's what we do here. If you create a field ID tab that is called coap option, we create another that is called TCP option. We create another that is MQTT option. That's just the role of the working group of someone else. If he wants to do his own protocol, he creates this. And then after that, he adds the value of the option.
But then why do you need space ID?
I told you it's to make the difference between the TCP. For example, you have a rule. You receive a packet that has option that has just an option. The option is either TCP or UDP, and it's the same value.
Yeah,
Make the difference.
Laurent, I understand this. It's just so like it's just a minor technicality. But what? So my question is, why don't you reuse the field ID? So it's named today field ID, but you can say, hey, I have a special field ID that is called.
Yeah, I do that. But if I do that, I need after that to put the value, the option values, and this option value has to enter into the key to specify which entry we have in the database.
You make the field ID part of your key.
Yeah, field ID and option value.
Yes, and then you don't need a space ID.
But field ID, yeah, but if I do that, I cannot. A key is mandatory. It means that I have to put option values in all the representation of my database, and it means that I had 1 byte in each query I will do to the database. So I think it's really necessary only for option and not for the rest.
Okay, well that's like a young particularity. Okay, let's take that offline. But I think probably there is a way around it. But let me read the draft and I can get back. Yeah, so that's for me. Quentin?
Yes. Well, first of all, thank you, Laurent, for this solution. It seems it could solve the problem of those options that appear and that were not originally there when the rules were first described. Something that we might have to think about is how do we do the reconstruction of the packet? Because it seems that in this case, since we are exposing the option values and not the delta values, it means that when we receive the SCHC compressed packet, then we need to rebuild all of the delta values using increments from all of the values of the options. And
for me, it's not a problem. It's really delta or not delta is a parser and unparser problem. If you keep in mind the previous value, he can use the delta. If he doesn't keep it in mind, or on the opposite, of course, decompress.
It's not. I mean, it's feasible. What I'm pointing at is the fact that we are pushing complexity into the unparser or the reconstruction of the packet by forcing the piece of code that will do the reconstruction to kind of like have logic that is specific to each protocol.
Yeah, but
so it means that the way we're going to
but that's
deal with,
yeah, I agree, but that's also the philosophy of SCHC. It means that we uniformize the header representation, and then we can apply a generic mechanism. And of course, this uniformization comes from the parser. Maybe we can work on more automatic parser, and that's another issue.
Yeah, but I believe this is something of interest. I mean, especially since we're saying that we want to be able to dynamically adapt to new traffic. In this case, this is simple. I mean, the format of the option is always the same. It's always a delta encoded option value followed by a delta some sort of length that is also encoded, etc. But the thing is it always the same in all protocols of interest? Is it possible that some of the options that will be added to protocol specification are going to have different ways of encoding on the wire? Meaning this is a simple case. This is kind of like a glorified TLV, but say that someone decides to introduce a new option that follows not a TLV, but some sort of different structure. So
I agree.
what happens in that case?
But I think we have to study this kind of protocols.
Well, I can tell you that some of the 3GPP protocols have that kind of niceties.
Okay, so I think it's good to see where we go. We made things without theory, and maybe it's good now to have more theory about header, to create a headerology discipline.
Yeah. No, that's not a criticism. It's just to point out that
no, it's open.
Between the two solutions, one is very straightforward. That is, this is the way. This is the kind of like unit fields that are going to be sent on the wire, and therefore you describe them all, and it costs a bit in terms of the length of the description of the packet, but then it makes the unparser very simple. It's just that you go through the rules and you just copy paste the values, the target values into the reconstructed packets, and that's very convenient because the unparser has nothing specific. You can use the same piece of code to reconstruct co-op headers, IPv6 headers. I mean, even NGIP headers as well. And obviously, the trade-off is that what you've mentioned before. So just pointing out that this is not only a question of rules description size that should be taken into account.
Yes, so we are almost at the end. I mean, the meeting has ended. I just want to probably just say something here. What Quentin is saying and what Laurent is saying is very interesting. And I think that probably there is a room for both to exist, in the sense that, I mean, if you have the abstract, the SCHC header representation, or the abstract header representation, which actually contains the options, that can be useful in some cases, and in other cases it could be useful to have the delta, the bits as they go on the wire, because the delta encoding is like the bits as they go on the wire, and the abstract representation is like when you interpret a little bit this delta and you get actually the real option values. And maybe one way forward is to have like a way to say like it's like to indicate that, to say, hey, well, here I have the option, but it's as it went on the wire, or well, here I have the option, but as it is interpreted already. If you understand what I mean. Yes, Quentin.
Yeah. I was going to say that's a very good idea. I believe that I mean the proposal from Laurent is very interesting because it keeps all of the good properties of having very compact rules and being very efficient in terms of compression. And I think that both could coexist. If I remember correctly, in the current data model, being able to support the kind of like raw approach would only mean adding the individual field IDs to the data model. So, I mean, we could do both and choose which one we want to use. And this could also prove interesting if we want to have very, very, very simple implementation on very constrained devices, devices where you wouldn't want to have protocol-specific code pushed to the SCHC compressor and decompressor.
Okay, so thank you very much, and thank you, Quentin. I agree with you. And yes, we'll need to see the complexity of that, but I think it can be, I feel it can be done fairly simple. But let's see how it goes. Thank you very much, Laurent. Thank you, everyone. So we are 4 minutes after the hour. So that ends our meeting. And we'll have our next interim in 2 weeks' time. So if you have topics to discuss, please send to the chairs or to the mailing list. Thank you all. And Marco, huge thanks for all the minute taking that you did today. Thank you.
Bye.
Bye.